Alright everyone, so here we have two examples, the next two examples in the lecture notes. Go ahead and get out your calculators, just follow along. This is a relatively simple example. Just make sure that you're getting the same answers because it's important that you type this in the calculator right, or else you're going to mess it up every time. So the first example, we want to determine the gravitational force between two children who have a mass of 35 kilograms that are standing 2.3 meters apart. It's important to remember that any two objects with mass are going to have a gravitational force between them. And so even two children standing 2.3 meters apart will still have some gravitational force between them. But you would assume, since we're all not just sticking together, that that force is relatively small. And so using the universal law of gravitation, we plug in the gravitational constant and the mass of each of the children, 35 kilograms each, divided by the distance squared, and the force between those two kids. (1.5 times 10 to the minus 8 newtons. So, a very, very small force. Next, we want to determine the gravitational force between a proton and an electron inside of a hydrogen atom. So we haven't talked much about these, but the mass of a proton and the mass of the electron are given here in the problem, as well as the radius of the hydrogen atom. We're just going to assume that the proton and the electron are separated by the radius of the hydrogen atom. And so again, to determine the gravitational force, we're just going to use Newton's universal law of gravitation. If we plug in the mass of the proton and the mass of the electron, and then divide by the distance between them squared, we find that the gravitational force between a proton and an electron inside of a hydrogen atom is 3.63 times 10 to the minus 47 newtons. So recognize that this is a really, really small force, but it's not zero, and it never will be zero. Any two objects with mass, separated by any distance, there will always be a gravitational force between them. Even if that value is essentially zero, it's not zero. Always keep that in mind whenever anyone tells you that there's no gravity in space or there's no gravity somewhere. Gravity is everywhere.